You guys know that when you solve quadratics, there's not just the traditional type of factoring. There's other types, like GCF and difference of perfect squares. The same thing is true of trig equations. If you were to attempt to factor and solve this quadratic 2x squared minus 4x equals 0, you would look at this and take out a GCF. 2x is the biggest thing that can factor out of 2x squared and 4x. When you take a 2x out, you're left with x minus 2. At this point, each of the factors gets set equal to 0, and then you continue to solve. So x equals 0, and x equals 2. 0 and 2 would be the solutions for this. The same is true of trig equations. If you look at example 1, we have 2 sine squared theta minus sine theta equals 0. I can think of something that can factor out of 2 sine squared and sine. The biggest thing that can is just a sine theta. If you factor or divide a sine theta out of both pieces, you're left with 2 sine theta minus 1 equals 0. This is the most common mistake. For some reason, people think sine divided by sine is nothing, but really anything divided by itself is 1. Just like before, you can set each of these factors equal to 0. So the sine theta equals 0, or 2 sine theta minus 1 equals 0. That means that sine equals 0, or sine theta equals positive 1/2. Now with these, I can think of 2 places where sine is positive. This positive number would happen in either quadrant 1, but also quadrant 2. The angle that has a sine of 1/2 is 30. So this is a 30-degree reference angle in quadrant 1 and a 30-degree reference angle in quadrant 2. Quadrant 1 is easy. That's just 30 degrees. Quadrant 2 is 180 minus 30, or 150. So this side of the equation has yielded 2 answers. Let's talk about sine theta equals 0. If you think about the sine curve, there's 3 places on here where this curve is at 0. At 0, 180, and 360. So 0, 180, and 360 are the 3 answers from this. Take a glance up at your domain. The directions for this section say that your angles, theta, are between 0 and 360, equal to both of them. That means that 0 and 360 are included in our answer, so for this, they count. There's 5 answers to this equation: 0, 180, 360, 150, and 30 degrees. If we were supposed to be looking for 5 answers, we found them. Pause the video and try the example below.
Hello, my name is Debbie. This is my first attempt, at a eHarmony video. This is my first time at online dating, so I'm nervous, but I'm excited at the same time. So I'm just gonna start talking about what I like and hope I get some replies. So I am a recent MBA grad from Villanova. I love cats. Sorry, I'm getting emotional. I love cats. I love every kind of cat. Sorry, I really love cats. And I just want to hug all of them, but I can't, because that's crazy. I can't hug every cat. But I just want to. I want to. I'm sorry. I get, anytime I hear cat, I love cats. Promised myself I wouldn't cry.
Just like some quadratics don't factor, some quadratic trig equations don't factor. This one, x squared minus 3x plus 1 equals 0, would not factor. But we're not stuck. There's still a way to solve quadratics that don't factor. And that is the quadratic formula, where a here equals 1, b equals negative 3, and c equals 1. Remember the quadratic formula, it's x equals negative b over 2a plus or minus the square root of b squared minus 4ac, and that is also over 2a. So here we go. Let's plug in. Negative b, negative 3 would be 3 over 2 times 1, which is 2, plus or minus the square root of b squared. Please, 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 square negative 3 in your head. Negative 3 squared is positive 9 minus 4 times a, which is 1, times c, which is 1. And that also is over 2 times 1, or 2. So x equals 3 over 2 plus or minus the square root of 5 over 2. Here is the answer to this quadratic. We're going to solve the quadratic trig equations below in the same exact way. Just like the quadratic above, this quadratic trig equation won't factor. So before we get started, let's move the 9 over to the other side. And here we go. We're about to use the quadratic formula to solve this trig equation, where a here equals 6, b equals 7, and c equals negative 9. Now keep in mind, we're not solving for x anymore. What we're trying to solve for is sine theta. We're trying to get sine theta alone. So our quadratic formula doesn't start x equals now, it starts sine theta equals. The rest, though, is the same. Sine theta is still going to be negative b over 2a, plus or minus the square root of b squared minus 4ac, and that is over 2a. So here we go. Sine theta equals negative 7 over 2 times 6, which is 12, plus or minus the square root of b squared, that's 49, minus 4 times a, which is 6, times c, which is negative 9. And that is over 2 times 6, or 12. At this point, I highly recommend you type in 49 minus 4 times 6 times negative 9 in your calculator to calculate exactly what that is. 265 should be the number underneath the radical. So at this point, we see that the sine of theta is negative 7 over 12 plus or minus the square root of 265, and that is over 12. Now with normal quadratics, we generally leave it like this, but this does not look like a sine at all. In fact, we don't even know if these numbers are positive or negative. So here, what I want you to do is type in your calculator exactly as this is. One of these branches is going to be the positive version, the other branch is going to be the minus version. This branch, you should type in negative 7 over 12 plus the square root of 265 over 12. And this other branch should be the negative 7 over 12 minus the square root of 265 over 12. When you type this in, you should make sure it looks exactly like this. Negative 7 over 12 in a fraction plus the square root of 265 over 12, also in a fraction. Once you hit enter, we have a decimal approximation for this value, about 0.773235, etc. Write this whole number down. As far as the other one goes, you can just take your calculator, arrow up to get that last thing you entered, hit enter, and backtrack to just change one thing, that plus sign to a minus sign. Hit enter, and you see the other value, negative 1.399. Something should really stick out to you about this number. This number, negative 1.9, can never ever be the sine of an angle. Sines are always between negative 1 and 1. So that means that no answers come from this branch. This one, though, will give us some answers. This is a positive number, and I know two places where sine is positive, quadrant 1 and quadrant 3. The only problem is I don't memorize an angle who has a sine of 0.773. We can use the calculator, though, to figure this one out. I can simply type in my calculator inverse sine or second sine, and then go up and get that 0.773 number. Once I hit enter, I get my angle. 50.6 degrees is the angle that has this sine. The directions say round to the nearest tenth, so let's leave it as 50.6. In quadrant 1, there's a 50.6 reference angle. In quadrant 2, a 50.6 reference angle. In quadrant 1, that's just the angle, 50.6 degrees. In quadrant 2, that's 180 minus 50.6 degrees, or 129.4 degrees. For this one, we were looking for two answers, and we found them. 129.4 degrees and 50.6 degrees. If you need to rewatch this video, do so. If not, try the example below.
So anyway, I am a cat lover, and I love to run. I'm sorry, I'm thinking about cats again. I think about how many don't have a home and how I should have them and how cute they are and their ears and the whiskers and the nose. I just love them and I want them and I want them in a basket and I want little bow ties. I want them to be on a rainbow and just in my bed, and I just want a house full of them, and I just want to still roll around. I can't.